factoring polynomials in the form of x squared plus bx plus c, what we are doing is undoing the FOILing, the multiplying that you learned in the last lesson. So our target is that we will factor trinomials in the form ax, that should be a squared, there we go, plus bx plus c, where a equals 1 only. And what that part means is that you do not have a coefficient in front of the first term. That is something that will be addressed in Algebra 2. However, it is something that I think you could figure out at this point if you were to see that on some other type of, like a STAR math assessment or something like that. But for now, we're going to keep it simple where there will not be a number in front of that x squared term, meaning that that a term is 1. So remember that factoring is undoing the distributive property. We use the FOIL method to distribute when multiplying binomials, and with binomials that's going to be something like x plus 2 times x plus 5. To do that, we FOIL. We do x times x is x squared, x times 5 is 5x, 2 times x is 2x, and 2 times 5 is 10. You combine that, so you have x squared plus 7x plus 10. So therefore, we can connect all that, and we can say, therefore, to factor a polynomial, you are undoing the FOIL method. So here's an example. If I have x squared plus x minus 20, what you're going to learn here is how to figure out that that equals these two binomials being multiplied together. X minus 4 times x plus 5. Now I can prove to you that those are equivalent because we can kind of roughly FOIL this in our head. X times x is x squared. The outside terms would be 5x. The inside terms would be negative 4x. And the last terms would be negative 20. So then you can combine 5x and negative 4x to be positive x. So we're going to be seeing some strategies to figure out what those binomials are that multiply to get your starting polynomial. So how do I do this? And basically it is a logical guess and check. That's the best way I know to explain it. We're not just throwing in random numbers. We're going to be logical. We're going to be thinking about some of the restraints of it. So if you have r squared plus 11r plus 24, what I'm trying to figure out is what are some numbers that multiply to get 24, but yet they add to be 11. Now you could potentially do all this in your head. However, I think it's easier, and for most of you, especially starting out, if you have some sort of framework to organize this, and we call this the columns. So you would make 2 columns. One column is the factors of 24, meaning what numbers can I multiply to get 24, and then if I add those factors, what is the sum of those factors? So let's start with 1. 1 and 24, those are factors of 24 because 1 times 24 is 24. When I add those, I get 25. So that didn't work because I'm wanting this sum, I'm wanting that to equal my middle term. So that didn't work. So the next set of factors I have are 2 and 12. 2 times 12 is 24. 2 plus 12 is 14, so that doesn't work. So that first line, that second line did not work. Let's try the next set of factors, 3 times 8. That is 24. When I add 3 times 8, I get 11. It matches up. Therefore, these are my factors. 4 and 6 doesn't work. You would potentially have stopped after that because 4 plus 6 is 10. You would have gotten your sum of your factors. So, but that just shows that that one does not work. And so, another point of having a logical guess and check is when the B and C terms are positive. When I have positive 11, positive 24, then everything is positive and I don't have to worry about negatives. But those are going to be some examples we're going to look at next. So since I know that 3 and 8 are the factors, I can put those into my parentheses. It's going to be r plus 3 because it's a positive 3 and r plus 8. So I can roughly kind of FOIL that in my head to check it. R times r is r squared. Then I would have 8r for the outside terms. I would have 3r for the inside terms, and my last terms would be 24. And so, oh yeah, 8 and 3 do add to be 12. So that is my correct factorization. R plus 3 times R plus 8. What I wrote in red down here, that was me foiling into my head to kind of check my work. Let's see a different example. Y squared minus 6y plus 8. So you see that my B term is negative. So when the B is negative but C is positive, that means, well, I have an extra phrase in there. When B is negative and C is positive, all of the factors are going to be negative, meaning that what's going to go in my parentheses is going to be y minus something times y minus something. I know that because if I'm adding two negatives, I'm going to get a negative sum. However, if I multiply two negatives at getting my last term, I'm going to get a positive. So since the middle term is negative and the outside term, the last term, the C term, is positive, that means all my factors are going to be negative. So let's make our columns again. I need the factors of 8, and I'm going to find the sum of those factors. Now all these factors are going to be negative. So I could have a -1 and a -8. When I add those, I get -9. So that one did not work. Let's try another one. So the next set of factors would be -2 and -4. When I add those, I get -6. There is the one that works. So I'm going to have a -2 and a -4. As you'll see, it's not going to matter if it's y minus 4 and then y minus 2. That is irrelevant. It could be in either order because what's happening is I'm multiplying those two binomials. Multiplying is commutative, therefore the order does not matter. Check it in my head. If I add -2 and -4, I do get -6. And when I multiply -2 and -4, I do get +8. So there is my factorization. So the key to this is the columns. The columns are what prevent you from sitting and staring at it and then having to guess and check and guess and check and guess and check. This kind of gives me a little bit of focus in my guessing and checking. Let's look at a different situation. Here, the B term is positive. The C term is negative. So when B is positive and C is negative, it's going to take a little bit longer because all the factors are going to have a different sign. Meaning that it's going to be n plus something in this binomial, and it's going to be n minus something in this binomial. I know this is the case because when I add them, I end up with a positive, but when I multiply them, I get a negative. In order to multiply and have a negative product, that means I have to have different signs. Now, another piece of information that I can keep in my head is since I add to get a positive, a sign war is going on. That means my positive number has to be the greater number. So here are our columns. We're thinking about factors of 36. Different signs. 1 and -36 would add to be -35. That doesn't work. Likewise, -1 and 36 would be +35. Next set of factors would be 2 and 18. So 2 and -18 give me -16. -2 and 18 would give me +16. We can see we're getting closer to the 9. 3 and -12 would give me a -9. And -3 and +12 give me +9. So there it is. There's the one that works. I don't even have to worry about 4 and -9. That would give me a sum of -5, and 6 and -6. I don't have to worry about those. So it's going to be -3 and 12. That means I'm subtracting the 3 and I'm adding the 12. Check that in our heads. If I add +12 and -3, I get +9. If I multiply +12 and -3, I get -36. So that is my factorization. Now let's get just a teensy bit more complicated. Let's factor a trinomial with 2 variables. So what this tells me is that I have an m as the first term in each of my binomials. I know that because m times m is m squared. But in my second term of each of the binomials, I'm going to have an n. I know that because it is n squared. Now I have a positive B term and I have a negative C term. So that tells me that one of them is going to be adding and one of them is going to be subtracting. That's because a positive times a negative is a negative, and then I can add them and have, after a sign or, a positive difference. So let's look at our factors. Factors of 27, that's still what I'm thinking about. 1 and negative 27 adds to be negative 26. Negative 1 and 27 add to be positive 26. That doesn't work. So the next set of factors would be 3 and negative 9. That has a sum of negative 6. Negative 3 and 9 has a sum of positive 6. So there are the numbers that I need to work with. The negative 3 is going to go here because it's the subtracting one. And positive 9 is going to go here. So let's FOIL this in our head. M times M is M squared. Outside terms would be negative 3mn. Inside terms would be positive 9mn. And positive 9 and negative 3 combine to be positive 6. And then my last terms, 9n and negative 3n, was going to give me negative 27. N times n will be n squared. So there is my factored version. I strongly suggest that you use the columns as you're working these out to kind of help to organize your thoughts, and it's going to make each of these factorizations a lot less daunting.